Thank you very much for the invitation to be here. I really happy to be. This is my first visit in Slovenia. I hope not the last one. And what I'll try to tell you today, I'll start with telling you about the Weizmann Institute somewhat, and then I'll focus more on the technology transfer operation in Weizmann Institute. So, you know, Weizmann Institute, the aim is to do basic science. And this is, we can define it as curiosity-driven research. So people don't come to Weizmann Institute to develop technologies, but come to understand nature, the rules of nature, curiosity-driven. And this is a research institute. It's not a university. It's like this place. We don't have undergraduate students and only graduates, master, a PhD, and postdoc. And we focus only on exact sciences. Namely, we have biology. Half of the research in Weizmann is in life science. We have two faculties in biology, life science, faculty of chemistry, mathematics, and physics. And one strong point, I think, of Weizmann Institute is the embedded multidisciplinary approach, because you probably know that nowadays, in order to attack important problems in science, it's not enough to bring narrow expertise, maybe in chemistry or physics or mathematics. Many times you need collaborations and bring expertise from several areas. And in Weizmann is not so big. People, they know each other, they collaborate a lot with each other. Even half of the staff in Weizmann, they live on campus. So they meet each other quite often. Even they go in the weekend to the playground with the children, so they meet and they very fast start talking about science, and this is strengths and collaborations. We have also high-level education program. First, we have a graduate school for the PhD and master, so we grant degrees. It's not from the university. We control completely the graduate students. And we also have operation for public education. We believe public education, Weizmann can contribute to that, and it's very important. Public education to maintain high level, important for Israel, important for the society, and important for Weizmann even to get the next generation of good students. So, and we have technology transfer operation, quite strong. Weizmann put a lot of effort in that. Even though we are doing only basic science, we also put effort in technology transfer. The fact that Weizmann is the vice president for technology transfer means that Weizmann put a lot of emphasis and importance on technology transfer, and we do this through a separate unit that we have, actually a separate company. The name is יידע. יידע in Hebrew is knowledge. As I'll show later, יידע was established many years ago in 1959, so we are doing this operation for quite a long time. So, few words about the science education in Weizmann. We have what we call Chlor Garden of Science on campus, where we have installations there close to science, and children can come play with these installations and they get acquainted with principles in science. And they like to come, and it's good. We bring into Weizmann classes and children from schools, give them lectures about science to try to attract them to science. We have what we call Davidson Institute on campus for science education. Mainly they teach also children, but mainly teachers from high school. We bring teachers from high school, give them, enrich their knowledge about science, because if the teachers are not good, nothing will learn about the teacher. So we try to do something about that. We bring also weak children from broken families there on the streets, and it's quite interesting and touching even to see that we allow them to do experiments, let's say, in a physics laboratory. We give them very simple experiments to do. We are sure they will succeed, and this is the first time in their life they succeeded in something. So give them some confidence. This is very good. And we have also Department of Science Teaching. They develop programs to teach science, chemistry, physics, mathematics in high schools. Most of the programs in Israel nowadays in high school that teachers teach are the production of this department. So, few words about the history of Weizmann Institute. Weizmann Institute was established by Dr. Chaim Weizmann. He was a chemist working in England, University of Manchester, and he came to Israel in 1934, before Israel state was established. It was Palestine until the British mandate at that time, and he decided to establish a research institute for organic chemistry. And this picture was taken, the name, by the way, was not Weizmann Institute, the name was Daniel Ziv Research Institute. Ziv family, they owned that time Marks and Spencer in London, and Weizmann convinced them to support the institute. And Daniel Ziv, it was their son that passed away when he was young, tragic circumstances, so they gave the building his name. This is a historical building in Weizmann. This is the same building. You can see the cars are different, and we have some trees around, but still it's the organic chemistry department. And my laboratory is here in the first floor. By the way, the name of was changed to Weizmann Institute in '49. This is the same year as your institute I have today was established. So Weizmann Institute, in a way, was established in '49 because that time it was widened to physics, chemistry, and biology. Before that, it was only organic chemistry, one building. So from this one building, today we have close to 100 buildings with very nice campus. You are invited. So actually, we have a tradition in technology transfer in Weizmann. Why? Because Professor Weizmann himself, he understood that if you are doing excellent basic science, many times you can extract application from that if you don't ignore it. And he tried not to ignore it. He himself, he had more than 100 patents at that time. And his most famous one was to produce acetone from starch by biotechnology method. And he transferred this technology in England to the British Navy, and they use it very effectively in the First World War for production of explosives. They need the acetone. And after the war, it became a common industrial method to produce acetone. And by the way, maybe this was the first example in history that you could gain political power through IP. Because in 1917, the British government gave the Jewish people what they call Balfour Declaration. And this famous Balfour Declaration declared that the Jewish people should have their own state in Palestine. And the story says that we got this important declaration because of the acetone, because the British government could not resist Weizmann pressure. Okay, in 48, Weizmann, when Israel state was established, Weizmann became the first Israel president. So it was very important that the first president of Israel was a scientist and from Weizmann Institute. So that time, universities and higher education in Israel flourished. They got money from the poor government that time because Weizmann thought it's very important. By the way, we had another president from Weizmann Institute in the early 70s, Professor Katzir, from life science. He also became Israel president. So if you are a professor in Weizmann Institute, you have a very good chance to become Israel president. It's 2 out of 9, it's good, good chance. By the way, Professor Katzir, he was a very famous scientist in biology. He passed away a few years ago, and he wrote autobiography where he wrote there that When in the government circle they talked about him to be the president, a friend of the government called him and told him, "Fine, they're talking about you to be the president." So he was very surprised and he asked them, the president of Weizmann Institute? So he said, "Don't exaggerate, it's only Israel." So I say, very important question is, what will be the next scientific revolution? And I think that I cannot answer that, and I don't think that anybody can answer what will be the next scientific revolution. However, we believe in Weizmann that we can answer the question, who will make the next scientific revolution? And we believe that the next scientific revolution will be driven by scientists who have a multidisciplinary view of science, opportunity to take risks. This is very important for scientists, I think, to take risks. Good infrastructure to work, or excellent one, and freedom to think. So we try in Weizmann to do this by recruiting the best scientists we can, offer them excellent infrastructure, the best we can offer, and give them complete freedom, academic freedom to think also, and to choose their problems. We don't ask the scientists, even when we recruit them, what they are going to do. We don't ask them too much. We just try to choose them by the record and by their passion to do science. And that's what we believe, that if are excellent people, they will choose important problem and they will do excellent science. And I think it works quite nicely in Weizmann for the last 60 years or more. One maybe criteria, I just want to show you this also, it's good for Israel, the ERC grants, starting grants in 2013 call. You can see that Israel is number 3 here. UK is number 1, Germany, Israel, in number of ERC starting grant. But if you do it per capita, Israel is number 1. Israel is very small. And most of this, many of these grants, 32, is Weizmann Institute. And the Weizmann Institute is first in Israel. So this is just one indication. I just want to show you what Paul Ehrlich said more than 100 years ago. Paul Ehrlich was a famous biologist in Germany. He got also the Nobel Prize, and he said that to succeed in science, you need 3 Gs. He said it in German, but I'll translate it into English. So the first G is gedacht, original ideas. This is also true for technology transfer, by the way. You cannot do good science without good ideas, original ideas, and also technology transfer. You have to get some ideas what to do with the patents and what application. The second G is geduld, patience. Results do not come very fast. As you know, also in technology transfer, results will not come fast. It takes a long time. And the third G, which is very important, is geld, is money. So also you cannot do good science without money. It's very important, and same thing for technology transfer. So, if you look at the development of patents, patent applications in the world, Charles Dole, he was the commissioner of US Office of Patents, and in 1899 he said that everything that can be invented has been invented. We finished. 100 years passed, and we know it's not exactly correct. And if you see, for example, the number of US patents granted from the end of 18th century to 2010, for example, we can see that number of patents applications started with the Industrial Revolution in the end of 18th century. But then there is a flood of patents in the last, let's say, 10, 15 years. Everybody applied for patents because everybody now appreciates more IP. This is good, but also has problems. So just if we look at the last, let's say, 40 years of this patent application in US, you can see that the number of applications, again, there is a big growth here. but the number of patents granted are not increasing so much. That's maybe two reasons. Maybe the Office of Patent in the US cannot cope with the number of applications, with the flood of number of applications in the US, but also maybe not all the patents applications are good for patents. So you get less. Everybody applies now. So, but I want to convince you that patents are good, but everything starts from basic science, and sometimes takes relatively short time, few years or more, to get to the market with some technology, but sometimes take very long time. One example, maybe known example, is the GPS. For example, GPS, you know, everybody is using it today, and the technology that the GPS relies on is the atomic clock. It's come from the atomic clock technology, and the atomic clock comes from the theory of relativity of Einstein. So Einstein didn't think about GPS, and it took 100 years for Einstein to come to GPS, but without Einstein, in his basic science, there is no GPS. So another example why basic science is so important, I think, for society, even, let's say, is the discovery of electricity by Faraday. Faraday experiments on electricity were driven by curiosity, but brought us in the modern era of electricity. By the way, at that time Faraday worked in London, in England. That time the Prime Minister of England, his name was Gladstone. His people told him that there is this funny guy that claims that he discovered something revolutionary, maybe you have to go and to see him. So the Prime Minister went to the laboratory, Faraday showed him the experiment, so at the end the Prime Minister asked him, okay, you show me all this, what can we do with that? So Faraday told him, I don't know what can you do with that, but I can assure you that very fast you will be able to tax it. So this is this is an example because that time what we had before the electricity for light, we had the candle. Okay. So now imagine that no amount of R&D, research development, on the candle could ever have done that to bring the electricity. So if we put R&D on the candle, so we'll have better candle, nicer candles, maybe longer time, but no electricity. In order to get this kind of electricity, you have to think out of the box. You think completely different, curiosity driven. This will become only from basic science. So that's the reason it's so important. Now, why should we do a technology transfer operation in a place like Weizmann or any other university? In a way, it contradicts the basic science, what we are doing. But there are several good reasons why to do it. First, technology developments. All the technologies I think we are using today, they are fueled by scientific innovation coming from academia. Many times people in academia didn't appreciate what they have in their hands, but somehow the private sector took this idea and developed it into products. Therefore, it's very important for the private sector, for companies, to take ideas from academia. And many times it's very difficult to pinpoint who did really the invention, or the real invention for the product. In that regard, I want to show you what Sid Kaiser said. He said, nice thing, I think, that the guy who invented the first wheel was an idiot. But the guy who invented the other three, he was a genius. Okay, so who made the invention here? So another reason to do technology transfer operation, I think it's what very important reason is what Niels Reimer said in 1987. Niels Reimer worked a lot with technology transfer in the United States. And he said that society, having funded much of the university-based research, has an expectation that the fruits of that research will improve human condition. Namely, universities, most of the universities in the world, Weizmann Institute too, are supported by the public, at least partially. So the taxpayer deserves and maybe expect that something good will come of his investment here. And if we have in Weizmann good ideas or good technology, it's our obligation to take care that they will come to society to improve human conditions. And we cannot do it without this technology transfer operation. We have to find patents and so on. Without it, the private sector will not develop these technologies. Just add to what he said, that society hasn't funded much too little of the university-based research, but this is another issue. Okay. So in Weizmann, I mentioned that we established a unit, a company, separate company, YEDA, in 1959, a long time ago. So we are doing this operation for a long time, more than 50 years. We were the first in Israel and one of the first in the world to do this technology transfer from academia. And we look at YEDA mission as two missions. First, to allow society to benefit from discovery made at Weizmann. And second, to create additional source of income to the Institute so that more independent research can be conducted. No, research become more expensive, more and more expensive, equipment become more expensive, you have to exchange the equipment more frequently, and support of government in general, it's true for Israel, but also for other countries, is declining. So university, I think, have to think what to do in the future about it. And one way to attend this problem, only one way, is technology transfer. Before I go more into technology transfer, I just want to convince you that it's very difficult to make predictions, especially about the future. This Niels Bohr said before. And so if you do basic science, you don't know what will come out of that. You just have to try to do excellent basic science. And I just want to show you a few sentences that smart people say when they try to predict the future, they made big mistakes. So, for example, Ari Warner from Warner Brothers Hollywood Movies in 1927, where it was the silent movie, he said, "Who the hell wants to hear actor talk?" Thomas Watson, he was the chairman of IBM, a very successful chairman. In 1943, he said, "I think there is a world market for maybe 5 computers." IBM still exists. But just 4 years, 1977, before the first PC entered the market, Ken Olson, he was the president chairman of Digital Equipment, he said there is no reason for any individuals to have a computer in their home. And digital equipment doesn't exist anymore. So it's very difficult to predict also which technology, which patent will catch the market. So you have to work with many, so some will do it. But when you are doing technology transfer, you have many problems, and one of the difficult problems is that there is a big gap between academia and industry. Okay? The technologies that university or research institute they have usually they are early technologies developed in laboratories. They are far from being products in the market. They need a lot of development, time, money, manpower, and so on. So when we approach the industry, we have them offer our technologies, they will say, okay, you have nice ideas, but for us, for the companies, the risk to take it is too high. And they require many more experiments, proof of concept, and so on to consider that many times we cannot provide. So maybe you are aware of this phrase called the Death Valley. So this is a nice Yosemite Park Valley, but it's a Death Valley. So many good ideas can die here, not because they are not good, but because nobody wants to take the risk. This is one of the major problems in technology transfer. We try in Weizmann, or also in Israel, to solve this problem, or try to solve this problem, also by we establish in Weizmann what we call BTG funds, bridge the gap funds. Not big money, but still we have money, and if some scientist found something and is still willing to or wants to push it further, but it doesn't have money because nobody wants to support it. So we have funds that we can support. Not big money, but we can support it for some time until maybe some the private sector will take it. The Israel government also have good tools for that. The Office of Chief Scientists, called OCS, Office of Chief Scientists, they have good tools. Namely, the government provides foundations, money, and we can approach together with a company these foundations, and if the project is approved, the government supports it for 2 years by 90% of the budget. The company only put 10%. And the company with us or alone, they work for 2 years, check the technology, try to see if it's good for them. And after 2 years, they have to decide if to continue by their own or not. This is a good tool. So we have also quite many incubators in Israel. They are designed, they are private incubators, also partially owned by the government. They are designed for early technologies, they are good for that. The problem is that they don't have enough money. So they don't provide much money to the companies, to the startups. We try to work a lot what we call angels. This community in Israel was until recently quite good, especially until 2008, the financial crisis. Maybe you read the book Startup Nation about Israel, that we have in Israel many startups, develop high-tech industry, and this is due mainly to young people. Maybe it has to do with the character of Israelis, young people that are not afraid of failure. This is very important, and they look for adventures. High risk, high gain. If you come to Israel, you can see how it drives, so it's a connection. And these young people are, what I said, they are not afraid of failure. This is very important. That means if they fail with the project, it's not a disaster, they don't commit suicide, they go to the next project. So even the next project, they are more experienced, they have some value, added value. I just want to show you, we talked about Israel, the expenditure on civilian R&D, the percent of the GDP. Israel relative to OECD countries. So Israel still is number one with 4.5% of the GDP. By the way, most of the money is not government money, it's private money. And usually people believe that above 3% it's okay. Not many countries are above 3%. It's only Sweden, Finland, Japan, and Korea. Switzerland is close. Maybe it's interesting to see who is the end of the list. So it's Greece, Spain, Italy, Russia. That's maybe connected to the problems they have, economic problems. I also want to show you this graph, and this is Israel relative to OECD and G7 countries in debt GDP ratio. So in the 80s, Israel was in very bad shape. Okay, the ratio of debt to GDP was close to 300%. And then there is a big drop here in the 80s and beginning of 90s, and slowly, and now we are better than OECD and the G7. This is a miracle. So, question, what happened here? I think we can say that mainly two things. First, the government took that time good economic decisions. The economy was in very bad shape and they took difficult and good decisions. And second, the startup high-tech industry started to flourish in Israel at that time. And that's this startup, until then we export oranges, agricultural products, to Europe or to the world. From that time, we started to export high-tech. And that's make a big difference on the economy, and still today. So I mentioned that Weizmann Institute is doing technology transfer for a long time. We have, I think I can say, we have experience in that. And naturally, over the years, we had many failures and did many mistakes. But naturally, I will not tell you about the failures. I want to tell you about few success stories. And that's also will tell you what can you do with the technology transfer and what are some of the difficulties. So we have a drug in the market called Copaxone. This is indicated for multiple sclerosis. It's a new class of drugs for the treatment of this disease. This disease is a very difficult disease without a cure, but Copaxone and also other drugs, they help the patients. And it came from basic science. In Weizmann Institute, the basic science was carried out in the late 60s. And people in Weizmann, they didn't, in life science, they didn't mean to find a drug. They wanted to understand the mechanism of the disease. And in order to study the disease, the mechanism, they had to study it in mice. So you have to induce the disease, multiple sclerosis in mice. That time it was, no, now you do it. So they looked for a compound to induce the disease, and they noticed that one compound, instead of inducing the disease, it was anti-disease. So they didn't neglect it, and they continued to work on it. And we Yeda filed a patent, the first one in 1971. And then we faced the death valley. Nobody wanted to take this technology, nobody believed in that. But we continued to hold the patent, and the scientists continued to work on that. They had more experiments. And then it took us 16 years, until 87, then that we convinced a company in Israel, Teva, maybe you heard about Teva, to license this technology. Teva nowadays is a giant, but that time also they were quite big, but they were and they are still mostly generic company. So they don't develop their own drugs. I think companies also in Slovenia, they are generic. So they hesitated a lot if to take it or not to license it, because they didn't have experience in that. And I think that also in 87, if they knew what they are going to experience in the next 10 years, they wouldn't license it. They had many problems, they worked on it 10 years, they wanted to give it back to Weizmann, but in the end, now everybody is happy. Because in the late 90s, it passed the FDA, it entered the market, and the sales in 2012 were of $4 billion worldwide. And this year, 2013, 4.2, I think. And the market share is 37% of multiple sclerosis market. So we are very happy about it, not only because the royalty we still receive, but also because so many patients around the world enjoy Weizmann technology. So it fulfills our mission. We have another drug in the market called dobitnika. This is also indicated for multiple sclerosis. It's completely different technology, was developed by a completely different group in Weizmann. Today is marketed worldwide by Merck Serono. Serono is a Swiss company, pharmaceutical, that was 4 years ago, I think, was bought by Merck in Germany, so it's Merck Serono. In the beginning, we licensed it in '82 to a small company in Israel named Interpharm, and Serono bought Interpharm. So the sales of this drug in 2012 was 2.3 billion euros. And the market share of this drug is 32%. So Weizmann technology is controlled close to 70% nowadays, 70% of the multiple sclerosis market. It's amazing. Small place like Weizmann did that. Now these drugs face competitions, but it's okay because after so many years, maybe better technology, better drugs coming to the market. I want to show you some example from mathematics. So, in Faculty of Mathematics, the group of Adi Shamir is a famous scientist in encryption. He developed encryption algorithm. We didn't know what to do with that in the beginning, but Yeda filed a patent in 1986. Generally, Yeda filed patent on everything that moves, and then after that we see what to do with that. So after that, we got the idea that it can be used for conditional access. In a minute, I'll tell you what I mean. It was licensed to a startup companies in Jerusalem, in the 90s, early 90s, and then very fast it was purchased, the startup was purchased by Rupert Murdoch. I don't know if you know the name. He's a billionaire from Australia, started to work with satellite and so on, so he has nowadays a very big group, News Corporation. He established this company named NDS, and NDS, what is doing conditional access, namely if you are watching TV, satellite TV or cable TV, and the company wants to control what you are watching according to what you are paying. So they do it by this algorithm. You have a decoder, smart card on the TV, and the smart card is based on the algorithm. Now it's better than that time, but still, so the company NDS sells these smart cards. Their turnover is more than $1 billion annually. Nowadays, NDS was bought by Cisco, so it's owned by Cisco, but still we receive royalties. So if you are paying your company, please continue to pay because something is coming to Weizmann. So I don't know in Slovenia because they have competition, so not the NDS doesn't control all the world, but still it's a major part. Okay, so this is another example, and I want to show you one example from chemistry. You know, now everybody is working in nanotechnology, but not many products in the market from that. We have a patent on nanoparticles. We call it nanoloop. It's a spherical organic nanoparticle that was developed in Weizmann. But then scientists, for basic science, but the scientists noticed that these nanoparticles, they are very good lubricants. So if you mix it, we had the idea, let's mix it with oil. And if you put it in an engine of a car or other engines, the engines run longer time, less friction, or on less gasoline. So we licensed this technology to a startup company in Israel, 2002. They worked on it like 10 years to develop the products. Now it entered the market, and we have great hopes in there. I want to show you one example from our pipeline, and this is a drug for type 1 diabetes. Developed by, in Weizmann, Professor Yaron Cohen, and this drug is in phase 3 now, last stage of phase 3, clinical trials. You know, that type 1 diabetes is a disease without any drug for that. The people, young people that they have it, they have to inject insulin every day or several times a day. If it enters the market, it will be the first drug for type 1 diabetes, so I hope very much it will enter the market. This is a unique peptide. It's based on a peptide, contains 24 amino acids, developed, as I said, in Weizmann, and it went a long way until we entered this phase 3. Many years, many companies, not one company licensed it, couldn't continue. We licensed to another, and so on. Several companies, but nowadays, it licensed to a company in Israel named Andromeda. Just last week, Andromeda was sold to an American company, that this American company should finish the clinical experiments, clinical trials. And again, I hope very much that it will be successful. So I think I can say that YEDA became a world leader in technology transfer. There are dozens of Weizmann insert products on the market. I can give you maybe just one number, that the total annual sales of products based on Weizmann technology in 2013 exceeded $23 billion. And we established many new companies around our technologies. This is job position and so on, is contribution to the economy. And we own the largest portfolio of patents in Israel. So I just want to show you now my view how you can succeed with technology transfer. So first, you need favorable environment condition for that. Namely, the legal structure in the country should be similar to Bayh-Dole Act, if you're familiar, to the United States. The Bayh-Dole Act says that the IP should be owned by the institution. If the institution does not own the IP, the government will own it, nothing will happen. And then it's very important to share royalties with the inventors. In Weizmann, they get 40%. In case of success, 60% go to Weizmann, 40% to the pocket of the inventors. This gives incentive to the inventors to do technology transfer. It's important to have government support program, incubators, and direct tech transfer support program, and very important to have developed venture capital community and entrepreneurs. If you don't have this community in the country, it's very difficult to do technology transfer from universities or institutes. It's very important to have also, I believe, internal condition for success in the institute or in the university for successful tech transfer. First, we believe in Weizmann that scientists should focus on excellence in basic science, not on the commercialization. Namely, they are very good in science, they are paid to do science, and they should stay there. This is the most important to maintain the basic science integrity. It also, if they are involved too much with the companies, it will, in the end, distort the research. That's what we believe. And also, it's not good for the companies. So, because usually I think scientists are not so good business people, even they think they are. So it's better that they will stay out of this operation. And in Weizmann, we don't allow the scientists to establish companies or to have shares in companies or to have executive position in companies. The only thing they can do with companies is to consult them scientifically up to 1 day a week, because we understand they know the technology and they can help the companies. But we also control the contract between the scientists and the companies. Scientists in Weizmann cannot sign a contract without Weizmann approval. So we control what they give to the companies and what they receive and so on. So if everything, we don't allow the scientists to do that, we need a proactive tech transfer operation to do all that, and a good one, a professional. And that's what we have in Weizmann. We have YEDA, and we have there also tech transfer officer that they have background both in business and in academia. So usually they have PhD in science. They are spending some time, few years in industry, and then after that we try to bring them back to Weizmann to work in the technology transfer operation. And it's very important, we believe, also to have clear internal IP rules. We have it in Weizmann, not only to have them, but also to enforce them. This is more difficult by the university management. So scientists should know exactly what they can do with industry and what they cannot do. And in Weizmann, practically, they cannot do much. So the scientists assign all the rights in the technology to Weizmann and to YEDA, and YEDA takes all the decisions, if to file a patent, maintain the patent or not, and do all the negotiations and running after the companies and so on, and try to license the technologies to the companies. By the way, we never sell, almost never, sell technologies or patent to the companies. We only license it. And the main reason is that if we sell the patent, the company can shelve it, not to develop it for economical reasons. And that's against our mission, that it will come to society. If we just license it and we put milestone in the contract and the company does not meet milestone, we can take the technology back and to give it to somebody else. So it's not a big celebration for us to take it, but we are doing that if we don't have any other choice. Now, however, maybe I describe you a smooth procedure of technology transfer, but it's not so smooth. It also creates problems between the operation in the campus, and problem between the operation and the outside world. The companies, they think differently from a university or research institute, different interests. This is conflict of interest. So I show always this slide which says that academy-industry cooperation is a love-making between hedgehogs. Okay? Is a desired activity that has to be exercised with extreme caution. Okay, so as I said, industry and place like Weizmann, they have different conflict of interest. There are, for example, many times companies come to us and say, okay, we'll take your technology, license your patents, but you don't publish in this area for a few years, for example. So, and we cannot accept it. You know, scientists, they want to publish not tomorrow, but yesterday, and that's academic freedom, of course. So we try to convince the companies, but if they don't accept, we don't take the contract. So we don't license the patent, because it's very easy to run after the money, but if you do technology transfer, you need to have your red lines. Okay, sorry. Okay, so you need your red line. So yeah, okay. So I think that's what I wanted to tell you today. I'll be happy to answer questions, and thank you very much for your attention.